Hello friends, welcome to Soul Mantra. In this video, discuss about integral transforms. This is our unit 2. In unit first, also discuss about complex analysis. Firstly, we know about integral transforms. Introduction. This is our concept introduction. The theory of integral transform afford mathematical device through which solution of numerous boundaries value problem of engineering can be obtained, that is conduction of heat, transverse of vibration of heat and a strain. In an integral transformation, given a different value and find out in a boundary condition. Also we discuss in a basic definition the integral transformation of f and p of a function fx defined as it is I f of x, also written as f of p equal a to b fx into k px and dx. K and P is known as a function of the P and X. This is also known as a kernel of a transformation. And P is called a parameter of the transform, and F of X is called inverse transforms of P. Okay, only change the parameters, so also change our the formulas. In integral transformation only discuss about the Fourier transformation. There is a number of the transformation: Laplace transformation, complex Fourier transformation, Hankel transformation and Millian transformation. So the basic concept of Laplace transform. When change over the kernel k p x e की power minus raised p x, so Laplace f of x written as 0 to infinity f of x e की power minus px into dx. This is our Laplace transformation. In a second, discuss only complex Fourier transform. When our kernel k p dot x equal to e की power I p x, when e raised I p x, then our integration minus infinity to infinity f of x e की raised I p x dx. So in this chapter our only discuss about Fourier transforms. The basic formulas of the Fourier transformation: fx equal to 1 upon pi 0 to infinity minus infinity to infinity f of t cos lambda t minus x dt into d lambda. This is our formula of the Fourier transforms. When you not know about Fourier integral theorem, so comment and also make a video for Fourier integral theorem. Then discuss what is our sine and cosine of the integral of a Fourier series. When you also describe cos lambda t minus x, cos just like a minus b, cos a cos b plus sin a sin b. When written as fx is put the value this 1 upon pi 0 to infinity minus infinity to infinity f of t bracket cos lambda t cos lambda x plus sin lambda t into sin lambda x dt into d lambda. When you consider this is 1 upon pi 0 to infinity, this is function of the t, so consider only the t. This is constant form, this is our out, cancel cos lambda x and limit integral minus infinity to infinity f of t and cos lambda t dt dt and d lambda plus same 1 upon pi 0 to infinity. Solve this and this is from t and the t, this is cancel out, only from sin lambda x and minus infinity to infinity f of t sin lambda t dt and d lambda. This is our the basic formulas. So decide where use sine and where use cosine. When the function fx is an odd function, so use sine formulas. Sine, this is sine formulas. F of x, the basic integral when you change the limit minus infinity to infinity 0 to infinity multiplied by the 2. This means when minus infinity to infinity, when you change minus 2 multiplied 0 to infinity, so just written as 2 upon pi 0 to infinity sin lambda x and 0 to infinity f of t sin lambda t and dt and d lambda. This formula use in odd condition and this formula use in even condition. How to check what is the function, odd function or even function? So put f of minus x equal to, when you find minus fx, this is function our odd function. Okay, when the function fx is an even function, when you function the even function, when you use formulas, this f of x same to same 2 upon pi 0 to infinity only include in the cos term, cos lambda x 0 to infinity f of t cos lambda t and dt into d lambda. How to check this is function the even function? This is function, put minus x, when you find fx in a positive term, this is function our even function. This is the basic concept of the integral theorem. This is a basic formula and sine and the cosine. This is the last result in a basic. What is a complex form of Fourier integral? This is called the inverse. F of x equal to 1 upon 2 pi minus infinity e की power raised minus lambda x minus infinity to infinity f of t e raised minus lambda t dt and d lambda. This is our formula in a complex term of the inverse function of a Fourier. Let's consider a basic example. Problem first, express the function fx equal 1 when mod x less than 1 and 0 when mod x greater than 1 as a Fourier integral. Hence evaluate 0 to infinity sin lambda cos lambda x upon lambda d lambda. By solution of a Fourier integral fx, we know f of x equal to 1 upon pi 0 to infinity minus infinity to infinity f of t cos lambda t minus x dt and d lambda. This is solution of the Fourier integral. This is our formulas. Next solve 1 upon pi 0 to infinity and minus infinity to infinity f of t equal to 1 f of t equal to 1. This is one term, cos lambda t minus x dt and d lambda. Firstly, we discuss only this term. This is given mod x is less than 1. When we out of a mod, this function sine term plus and a minus x is less than 1. So positive sign less than 1 and minus x, this is 1. Negative sign not accepted, this is term. So in multiplied minus x term, so x change the sign minus 1. It means this value x exit 1 when x less than 1 and x greater than 1. When consider in this form, when you basic term 0 and plus 1 and minus 1. So limit exit this and this term. Okay? And consider to find out mod x is greater than 1. When you find out mod x greater than 1, this is mod term sine out plus x greater than 1 and minus sine greater than 1. This is not acceptable. So minus multiplied by this is whole term minus x. This is 1. This means x greater than 1. X greater than 1, this is this side, and minus x less than 1. Sorry, minus x not acceptable. Minus 1. Okay, this is sign change. X is less than minus 1. This is our limit out of this form. And this is infinitive to minus infinitive. So this term not exist. When I consider this is limit 1 and 0. So exit minus 1 and t, this is whole term 1. And otherwise whole term is 0. Okay. This is our basic concept. Find out this limit. So our change the limit in this condition 0 to infinity also written as minus 1 to minus 1. Minus 1 to 1. Because this is only term mod x. When we found x is less than 1. X is less than 1. And x is greater than minus 1. So limit exit only this term minus infinity to infinity minus 1 to 1. And whole term also the 0. So also solve cos lambda t minus x dt and d lambda. Only consider this form. Not consider delta lambda. Only the form the dt. When you solve this 0 to infinity, when you also consider this is I form. This is very short. This is not considered. Cos lambda t minus x written as sine t or sine lambda t minus x upon lambda 1 to minus 1 and the d lambda. When you put this value 0 infinity to infinity sine lambda t 1 minus x minus sine minus 1 minus x and the lambda and d lambda. Solve this problem. Sine a minus b minus sine a minus b. Okay. So also the common term 1 upon pi 0 to infinity sine lambda. This is 1 minus x. Common term. This is common. Minus common. Here minus 1 minus x. Also include 1 plus x written as and plus sine lambda 1 minus x. 1 minus x. Also written as only simply form d lambda. When you apply the formula sine a plus b and sine a minus b. Sine a plus b, sine a cos b and plus cos a sine b. And this term sine a cos b minus cos a sine b. Cos a sine b, cos a sine b cancel out and find out 2 sine a cos b. So it's same like 1 upon pi 0 to infinity 2 sine lambda sine a and cos b cos lambda x upon lambda. To the constant term 2 upon pi 0 to infinity sin lambda and cos lambda x upon lambda d lambda, and fx is the 1. Okay, so also evaluate this 0 to infinity sin lambda cos lambda upon lambda. Okay, so final result, when you constant term transform this pi upon 2 equal 0 to infinity sin lambda and cos lambda x upon lambda d lambda. Thank you for watching this video, friends. Like, subscribe and comment.